Well, welcome. In this video, we're going to be starting a brand new unit on probability. Now, probability can be a really fun alternative to your traditional style of doing math. It has a lot of application, so some students really enjoy that. But one of the complicated things about probability is there's a lot of terms, and there's a lot of situations to keep track of, and we'll be watching those in these next few videos. Just to give you an example, we could have situations that involve the word or, and situations that involve the word and between two different probabilities. And those two events mean two completely different things. So that's where some students get hung up on, is just trying to keep track of all those different situations. But if you can keep track of those, probability can be a really, really fun unit. So I hope that's the case for you. Now, some tools that I've given you to help you out is you already have a laminated little card that has a bunch of dice on it. So let me explain what that's all about. Basically, that's a lot of the story problems that we're going to be doing is going to have these different dice on them, or involve rolling two dice, or even a spinner. If it's a problem involving a spinner with 6 sections and you're spinning the spinner 2 times, we can use this card. Now it's laminated, so in that way you can use, if you have a whiteboard marker, you can mark on it and then just wipe it off and use it again. It's also double-sided, so if you use a marker or use a pen and you can't wipe it off, you still have the other side. But that's meant to help you out when you do some of these problems as we work on our notes and even as you're working on your assignments. Now on a test or a quiz, I will give you that sheet, or give those that diagram on your sheet, so you will not be allowed to use that on a test because I will give it to you. So with that, let's begin by looking at some terminology that we should be familiar with in regards to probability. So first off, as you can see above me here, it says a situation with several possible results is called an experiment. Makes sense? Probabilities are a measure of how relatively often the results occur. Each result of an experiment is called an outcome. The set of all possible outcomes of an experiment is what we call the sample space for the experiment. Now, a sample space is always represented using these fancy brackets, is what I call them. It reminds me of cursive handwriting, and cursive handwriting is really fancy handwriting, so I just call these our fancy brackets. I don't know what the technical name is. I'm sure there's a better name, but let's just call them fancy brackets. It's more fun. So anyhow, if you ever have inside of those fancy brackets that little circle with a line through it like we have here, that just means what we call the empty set, meaning it's not possible. So if you see that looking at the answer key, that's just a short way of saying that the problem isn't possible. So let's start by looking at an example where we can write our outcomes, or the sample space, using some of those fancy brackets. So this example says a small box contains 30 blue, 30 green, and 25 red paper clips. 2 paper clips are taken from the box and their colors recorded. We want to list all the possible outcomes for the experiment. Now it's kind of tricky because at this point, knowing that there's 30 blue, 30 green, and 25 red paper clips really doesn't matter. What we want to just figure out is all the possible different types of outcomes. So the number of paper clips is not going to affect that. So for example, since we're going to list the possible outcomes, we're going to use those fancy brackets because we're coming up with what we call a sample space. So one of the possible outcomes would be we could get 2 blue paper clips, because there's no rule saying we can't have the same. So we're just randomly selecting 2 paper clips, and we could have 2 of them that are blue. Now we could have one that's blue and one that's green. We could also have one that's blue and one that's red. Now for these problems, the order doesn't matter, meaning if we had a blue and a green and a blue, it's the same result. So let's say if we didn't have a blue first, let's say if it was a green first and we had a green first and a green second. Like I said, having a green and then a blue is the same as having a blue and a green. So we're not going to list it again. But we could have a green and a red paper clip. Now what if we haven't had too many reds? So let's say if we have a red paper clip and another red paper clip. Would there be any more? No, because we've already had, because a green and a red would be the same as a red and a green, and a blue and a red would be the same as a red and a blue. So there are no more. So that ends our sample space, so we close it off with another one of those fancy brackets. So now the question says, how many outcomes are in the sample space for this experiment? Well, you just count them up, and there's a total of 6 outcomes. So that's just using some of that terminology that we just talked about. Here's another term for you. An event is any subset of the sample space of an experiment. So, for example, to find the definition, or to define the probability of an event, let's look at this table, or this box here. All those words aren't meant to confuse you. An easy way to look at that is we could just say the probability of an event is that fraction. It's the number of outcomes in an event over the number of outcomes in a sample space. So let's look at an example so you can see what we're talking about here. Let's say if we want to find the probability of rolling 2 dice and getting doubles. So this is where we're going to use that dice card. So if you look at that dice card, we want to find the probability of getting doubles. Well, that happens here. So that happens a total of 6 out of 36 times. We never leave a fraction unreduced. So if we can reduce something, if we can reduce a fraction, always reduce it. 6 over 36 reduces to 1/6. So we have a 1 in 6 chance of rolling 2 dice and getting doubles. So I want you to see if you can figure out the probability of getting a sum of 10. So use your dice card and see if you can't figure out the probability of rolling 2 dice and getting a sum of exactly 10. Okay, let's see how you did. So you should have noticed that there's 3 times that we had a sum of exactly 10, which reduces to 1/12. So that's how we could find the probability of an event. Now when a sample space has n outcomes, all of which are equally likely, then the experiment is called fair or unbiased. And each outcome has a probability of 1 over n. The outcomes are said to occur randomly. What does all that mean? Well, let's say if you're flipping a coin. There's 2 sides of a coin, so there's 2 possible outcomes. Getting a heads or getting a tails are both equally likely. So that would be a fair coin, as long as a coin isn't weighted where one side would be favored over the other. And each outcome has a probability of 1 over 2. Or let's say if you have a spinner, as long as every section is equally as the same size, let's say if there were 4 sections on that spinner, well, n would be 4, so you'd have a 1 in 4 chance for each section. And again, it would be fair as long as each section was the same space, or the same size. So let's look at this example. It says an experiment consists of tossing 2 fair coins and counting the number of heads. Consider the events of getting 1 head in all, getting 2 heads in all, or 0 heads in all. And are these events equally likely? Well, to start out with, we need to come up with a sample space. We want to figure out what are all the possible outcomes we could get with flipping 2 coins. An easy way to do this is to create a tree diagram. Here's what I mean. On our first toss, we could get heads or we could get tails. Now we're going to have a second toss. And on that second toss, now let's say if we got heads on the first toss, well, on that second toss we could get heads or tails. Or let's say if we got tails on the first toss. On the second toss, we would also have the choice of getting heads or tails. So when we look at the outcomes here, we would look at this across. So we would say that we could have heads, heads. We could have heads, tails. We could have tails and heads. Or we could lastly have tails and tails. Those are all the possible outcomes of flipping 2 coins. So now, as far as the probability of getting 1 heads, getting 2 heads, or no heads, now no heads would be nothing but tails, well, those are not equally likely. Because the probability of getting 1 head in all, well, that we can see that there was 2 times where we only got 1 head. All those 4 outcomes, that reduces to 1/2. Probability of getting 2 heads, that happened once, or 0 heads, that happened once as well. So that was 1 over 4 and 1 over 4. So they're not equally likely. Let's look at another example. A researcher is studying the number of boys and girls in families with 3 children. Assume that the birth of a boy or girl is equally likely. We want a sample space. Now this time I'm going to create my sample space. Instead of going vertically like the previous one, I'm going to list it out horizontally, just so you can see how it looks, and you can decide for yourself how you prefer to do these. So we would have our first child. Our first child we would have a boy or a girl. Now make sure you give yourself plenty of space between these two, because we're going to have 3 children, so we're going to have 3 branches coming off of each of these. Here's what I mean. Actually, not 3 branches, but we're going to do this 3 times. So for the next child, well, if we had a boy for the first child, for the second child we would also have the option of having a boy or a girl. If we had a girl with the first child, we'd have the option of having a boy or girl for the second child. Now we're going to do this a 3rd time. So for the 3rd child, this is what it would look like. So we'd have branches of boy or girl coming off of each of those previous children. So to list these possible outcomes, we would read them by the branches. So again, boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, and girl, 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 which are all listed over here. Now the question is asking us to find the probability that a family of 3 children has exactly 1 boy. Well, we can look at our outcomes, and we can see that there are 3 times where we have exactly 1 boy out of all those outcomes. So the probability of that happening would be 3 out of 8. That doesn't reduce. Now we could also change it to a decimal, which would be 0.375, or change it to a percent and write it as a 37.5% chance of having 3 children, and one of those, exactly one of those being a boy. Now let's look at the next example. It says, again, assume the births of boys or girls are equally likely. How many outcomes are in the sample space for families with 4 children? Now I don't want to take the time to redraw this table, so I'm just going to add to it. This time we're going to have a 4th child, so we'd have branches coming off of each of those previous for the 3rd child. Now the next question for part A, it says how many outcomes in the sample space for families with 4 children? So to figure out all the possible outcomes, really I just have to count these bottom pieces, because these bottom pieces represent 1 outcome, because we could have boy, 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 girl. So those are 2 outcomes. So I'm just going to count those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's a total possibility where we could have 16 different outcomes with 4 children. And the probability that of those 4 children has exactly 1 girl and 3 boys, well, that's what I started highlighting here by accident. Well, here we have 3 boys and 1 girl. This branch has 3 boys and 1 girl. This branch here has 3 boys and 1 girl. There's only one other one where we have 3 boys and 1 girl. So there's 4 possible outcomes out of 16. So we have a 1 in 4 chance of out of 4 children having 1 girl and 3 boys. So that's how we can use those tree diagrams to help us figure out how many outcomes there are, and how we can use that also to find different probabilities. Now let's understand some terminologies here and some basic properties of probabilities. So let's start there in that box. So all this is doing, again, is just giving us some properties of probabilities. This first element, or this first piece, is just saying that the probability of an event is always going to be between 0 and 1. Now it could also be exactly 0, meaning it's impossible to happen, and it could be exactly 1, meaning it's always going to happen, or anywhere in between. Now if the events equal the sample space, that's what the E and the S represent, then the probability of the event is going to be exactly 1. If an event isn't possible, then the probability of the event is going to equal 0. That's all that's saying. Now we've talked about relative frequency. So let's talk about when the relative frequency equals 0 versus the probability equaling 0. That means 2 different things. Remember that relative frequency, that's what we learned about in the first chapter, is the number of times an event occurred over the number of times it could occur. So having a relative frequency of 0 doesn't mean that it's not possible, it just means it hasn't occurred yet. So for example, let's say if we're flipping a coin 4 times, and all 4 times we've gotten heads. Well, the relative frequency of getting tails would be 0 out of 4, because we flipped a coin 4 times, and 0 times it showed up as tails. 0 over 4 would be 0, so your relative frequency would be 0. So that doesn't mean it's not possible, it just means it hasn't occurred yet. But having a probability of equaling 0, that means it isn't possible. So those are just some properties there, some different terms to be familiar with. So that's it. So hopefully this first section hasn't been too awful for you. So good luck now as you work on your assignment.